Okay, so here are a few extra problems to kind of help out with the homework in 6.1. The whole section is about working with interior and exterior angles of polygons, and specifically convex polygons. If they have caves in it, it throws everything off. So the first thing is that there's a formula for the measure of the interior angles of an inside polygon, a convex polygon, and that is n. It's right here, but I don't know how well it'll show up. So the formula is n minus 2 times 180. We talked about in class how when you take a shape like, I don't know, let's say a square, you can make it into two triangles, which it's four sides and two triangles. You could then do a pentagon, and a pentagon has five sides, and it makes it into one, two, three triangles. So basically it's the number of sides minus 2 because that's how many triangles you can make, and then for each triangle you get 180 degrees. So that's the formula. So I don't know, let's take look at a couple examples. The first one here says find the sum of the measures of the interior angles of each convex polygon. I don't know, let's start with maybe number 5, just as one to do. So it's the sum. So since it's the sum of the measures, that's where we're going to use that n minus 2 times 180 formula. So there are 12 sides, so 12 minus 2 times 180, that ends up being 10 times 180, ends up being 1800 degrees. So all 10 angles together would be 1800 degrees. Now, and they didn't ask this, but if they wanted to find like one interior angle then, if they're all the same, okay, for instance, they're a regular polygon, you would just take 1800 divided by 12, and you can use a calculator for that. 1800 divided by 12 is 150 degrees. So it'd be 150 degrees for one interior angle if they were all the same. If they're different, then that throws off everything. Now, number 11, working backwards from this is a bit more difficult because you don't know the number of sides. Now there's a formula that we talked about in class that if you know it's regular, you just take n minus 2 times 180, and then you divide it by the number of sides. That will give you the measure of one of those angles. So you can set it equal to 144, multiply both sides by n and solve from there, and they actually do an example up here of this. So we know each angle is 120 degrees, so 120 n, because just multiplying by n does this, cancels that off, equals n minus 2 times 180, go through and solve. They got 6 sides if each angle is 120 degrees. There's a much quicker way, though, than doing all this algebra, and it's this way. We already know, in the other part of the section, that the outside angles of a polygon, like here's one right here, the outside angles, all of them, this one it has 6 of them in this case, all of those add to 180. Sorry, not 180, all of them add to 360, excuse me. So we can add them all to 360. So if we could figure out the measure of an exterior angle, we can divide 360 by that much more quickly. So for instance, in a regular hexagon, each angle on the inside is 120 degrees. Well, each angle on the outside then is 60 degrees because they make a linear pair together. So 360 over 60 is 6 sides. Much easier problem to do. So that's the way I suggest you do this for something like number 11. You could use this algebra method the book likes to promote here, but I think it's more work than necessary. So in this case here, again, I know the interior angle is 144 degrees. Well, the exterior angle would be then 180 minus 144, which is 36 degrees. So if that's the exterior angle, and it's just one exterior angle, just one, okay, to find the measure or the number of sides, I just take 360 divided by 36 degrees. That gives me then 10 sides. Now it's specifically giving me 10 angles, but the number of angles is the number of sides, so that's not that big a deal. For another problem, like number 13, I'm not going to go through the whole thing because I want to keep this short, but it's a 1, 2, 3, 4, 5-sided polygon. It's a pentagon. So in order to find the value of x, what we have to do for this one is Figure out how many degrees there are inside of all 5 angles for a pentagon. So 5 minus 2 times 180. That's 3 times 180. That's 540. So it's 540 degrees total inside this polygon. So just add up all the angles, set them equal to 540. Set that equation up and then go and solve. Now, the other half of the section then is very, very similar to this. The difference is just that, again, we're working with exterior angles. So no matter what, I don't care how many angles you have, I don't care how many sides you have, the outside always adds up to 360. So for these 3 problems here, it's just the book trying to be fancy. Decagon, 16gon, 36gon. The question is, find the measures of the find the sum of the measures of the exterior angles for each convex polygon. All 3 of them are 360 degrees. Because it doesn't matter how many sides you have. If it's the sum, it's 360. And then you got here for 4 through 12, the question is, find the measure of each exterior angle of a regular polygon. Well, now, like for instance, number 6, okay, I know that they sum to 360. There are 20 sides, meaning 20 angles, so divide by 20, because they're all the same. Sorry. No. I can't divide all of a sudden. 18 degrees for each one. Knock off the 0, 36 over 2 is 18. Okay, so that's how we'd find the measure then of one exterior angle. Do the same thing for the rest of these if this were the homework. So hopefully that gives you a little bit of extra work on that, or a little bit of extra support for working through those problems.